Hi, welcome to 505 videos. This is DC here. This is the second video on how to use ISO15693 tags using PN5180 board. So this is the continuation of my previous videos. So I would advise you to see my previous videos before this. So these are the things I would like to cover in this video. So you're going to see the inventory command. You're going to see how that is used in the basic version as well as in the addressed mode, or you can call this as in a basic or a standard mode in address mode. And I'm going to show you how to identify three different types of iCode tags. This iCode SLI. This is the one you get when you buy this board from internet. And I also purchased the iCode SLIX and iCode SLIX2. So if you want to buy SLIX and SLIX2, you can find many sites selling this SLIX. However, there are not many sites that sells SLIX2. However, I'm going to put the URL of the site where you can buy this SLIX. So I'm going to show you a few commands. One command is to get the logs from all the blocks, and also going to mention about what are the custom commands. We're going to see how to do the fast inventory, and in fact if you have seen my previous video, we have already used two custom commands when I showed you how to log the AFI and the DSFID. So these two were part of the custom commands. You can see I have connected my board and the Arduino, and the version of the software I'm using is 1.8. If you look into the release notes, so when I did my last video, we were at version 1.6. So new tags were added to this software. Now we can read and write or learn how this ntag 210U and 212 works. You can also see how the MIFARE Ultralight C and ntag 203, and also there's a mention about few enhancements to this software on ISO15693 and few bug fixes as well. Now first thing you do is, the software automatically shows all the COM ports. So I have got only one device connected, so you see only COM4 and connect and choose the tag. So you can see there are so many tags here, and as I agreed before, I'm going to make videos once I finish with the ISO15693 tags. So if you got this software and if you want to use all these tags, please see my videos on all these tags. So the screens are exactly the same what's in my old videos. So here there's a small change in this release compared to the last one. So in this release, when you click on activate, before you do the activate, you have to set this RF on, and I'm going to activate this. Now this is the tag you got it when you bought this board. So activate. Now if you look at the series of commands, in fact I forgot to mention this in my last video. The very first thing you have to do with this type of board is you have to set the RF parameters. So we have seen this load in the configuration when we discussed about the MIFARE and MIFARE tags. So you have to know that the values of the RF configuration. If you just go to the console screen, so go to the configuration, there are two entries for ISO15693. It's ASK100.26 and ASK10.26. These two probably now, these are something to do with the way the modulation demodulation works. I'm not very comfortable in explaining these two things. It's 100% and the 10% thing, something like that. On the receiver side also you got two entries. That's the 8D and 8E, which is 26 kilobits per second and 53 kilobits per second. These are very straightforward. 26 is the low speed, and 53 is the high speed, high rate probably. So what you can also notice here is the difference between the value for the transmitter and the receiver. So I have used these two combinations. I have used 0D and 8D. So the difference between these two is the hex 80. At 80 here you'll get this number. So we don't need this thing now. In fact, if you really want to play with the low level commands, you can always go to this screen and start sending the raw commands and understand these commands very well. So here the first thing what I did here is load the configuration. So this prepares the board for to read and write with the ISO15693 tags. After that, I have used a inventory command. Inventory command is part of the ISO15693 specification. Now when you send this command to the tag returns the UID plus the DSF ID. So what the software has done is extracted out the UID and it has reversed it, because you get the lower byte first, whereas when you see this UID of ISO tags, you always see the higher bit on the left side. So this value is reversed and it is populated here. Now because this is the as I mentioned before, this is a iCode SLI tag. So I got two more tags to show you. So I bought few tags from internet. It's iCode SLIX. Now I'm going to activate that tag. You can see here the software says it's iCode SLIX, but I'm going to show you how to determine whether it's a SLI or SLIX or SLIX2. It's the same thing, the same command, the same inventory command. In fact, I could have avoided loading this configuration. There's nothing wrong here. The board doesn't throw any error if you try to load the same configuration again and again. So because this logic, it's all part of this the button, so it's loading it again and again. Now here also, as you can see, now the same inventory command with using the slot 1, and if you want to just go a little bit in detail, the 26 is the flag. So this tells you it's inventory command, and this is the slot 1. This is the simplest command you can use whenever you're working with a single card. Remember, you can work with the multi cards, but here in this tutorials, I'm using only single card. Now this is the value of this the UID. So starting from IC and goes up to here. So I got one more. This is also SLIX, but this is in the form of a label. You can see here. Activate. This is again the same thing. Now I got one more tag. This is the one I bought recently. These tags, I can see they are made from 3M. So when I activate this, it says it's a iCode SLIX2. Now the difference between SLIX2 and SLI is the memory capacity. SLIX2 has got a higher memory capacity. So if you want to know more about that, if you just go and hit the get. Now this command uses the get system information command, and it says there are 80 blocks and each block has got 4 bytes. So you can hit this read. If you got a SLIX2 tag with you, you can still do the read and write operations. However, the software is not ready to use all the commands or custom commands of SLIX2. Probably that will be available probably in a version maybe 10 or 11. So you can see that you can read all these 80 blocks. So next I'm going to show you what is the addressed mode is. So I'm going to go back to the tag you got with the board. This is the SLI, sorry. Now you can start all over again. Activate. Now get information. Now if you look at the command structure here, the get information is 02. The 02 refers to the data rate, using high data rate, plus 2b refers to the command. See, the best way to understand this address mode is to have a copy of the data sheet in front of you. Now this is the documentation of the specification of this tag, this standard ISO15693. So whenever you see this structure with the UID with the grade background, it means when this command is sent in the address mode, you have to pass the UID of the tag. Now the question is, where do we use the address mode? Now in my opinion, this address mode is used whenever you are working with the multiple tags. So but all my videos and the software is mainly to make you understand how this standard works. So probably I will not be spending I'll not be using multiple tags in this video series, but you have to know the concept here. So if the flag says it's a address mode, then the command must include the UID of the tag. So think about, you got 5 tags in front of the reader and you want to access all the 5 tags one by one. Now you can have all the 5 tags active and they will be in a quiet mode or in a not ready mode. Then you can start accessing, reading the tag one by one by using the address mode. And this is the documentation of SLI. And here if you go to this get system information, it says refer to this document, the specification. Okay, so what I'm going to show next, the same get information command but using the address mode. If you go to the system and you have to tick the address, when this is ticked, if you look at the value of the flag, it becomes 22. This is nothing but in an hex number of this 8 bits. Now if I go and hit get, you still get the same information, but if you look at the command structure, see, this was the get information command in the without address mode, where we send the flag followed by the 2b. Here you have the flag which is 22 followed by 2b. Again it has got the 8 bytes of the UID here. And keep in mind, when you send these 8 bytes of UID, you always send the lower byte first. It's the E4, 7D and so on. And the outcome is the same, this as well as that. So you can play with the address mode. Now I can do the entire tag operations using address mode. Now I can go and say hit this read. Now you can see here it reads, and if you look at the command structure, every read single block command is in address mode, and in every command the UID of the tag is sent. Similarly, you can go and write. Now I'm going to write, say, this one. I'm going to change this to, say, probably try this this one, 22. If you go and hit write, the write is successful. Again, this is address mode because the flag is 22 followed by the write operation followed by the UID. So you have to be very careful when you send this structure. You just cannot have in a different order. Now I'm going to show you an example of the write in the address mode. If you go here, so I'm going to go through a few commands with the address mode. If you look at the read command structure, you got the flags, you got the command code for the read followed by the UID followed by the block number. So you have to have the UID between the block and the block number. Sorry, the command code and the block number. So this is an example of a read in the address mode. So likewise, this is the write mode, the write single block command. You got the write command followed by the UID followed by the block number. Now this is an optional thing, so this is present only if the flag says it's an address mode. So next I'm going to show you a command called get multiple block security status. Now this command is used to read only the locked status of the entire tag or all the blocks in one single command. So again, this command can be run without address mode or with the address mode. So now we know if there is a single tag, you don't have to use address mode. You can just send a command, and the tag, whichever tag receives the command, will start replying. So to be careful when you have a multiple tags, if you send a command without the address mode, all the tags might start replying. So there will be a collision in the data. Now this is a very interesting thing, and it's very useful as well. So you can just assume that you want to know the locked status of all the blocks. So you don't have to issue any commands to read the data. Probably can just issue a command to get the lock status. And what I have noticed is the commands you find in this standard document sometimes may not be implemented or available in the tag. So this is a SLI tag. It says get multiple block security status is available, but also sometimes you will say saying that this command will work without with the address mode, not address mode, sorry. This command will work with option flag set or not option flag set, something like that. You have to be very careful. Now in the software, I could have got the locked status of all the blocks by setting this option flag, but now I'm going to show you a different way. If you look into this, see, two additional tabs have come here. Now the intention here is if the tag is a ICode tag, you will see all the ICode specific custom command feature here, and this tab is supposed to have all the standard all the commands that are mentioned in the standard. Now this is the command get multiple block status. So if I probably I can try this without address mode initial. Okay, so if you go and hit get multiple block status, now you can see that all this block locked byte is updated now. If you look at the command structure, now this is the command and this is what you get as an output. Now if you ignore the very first byte, this is the flag. So you can't ignore it, but yeah, this is the 00 means it's a success. So this is followed by so many bytes. There are 28 blocks in this tag, so you get 28 blocks. And 00, so 01 means it's a locked, and 00 means unlocked. So this is something it's a handy command to understand as well. Next I would like to speak about a command called write multiple blocks. So the command says this can be used to write more than one block in a single command, and the syntax of the command is also mentioned in the specification. So it starts with the flag, the write multiple block command, that is number 24. If you're in address mode, you have to pass the UID and the first block number, the number of blocks, and the data for all these number of blocks. Say if I'm writing data for 5 blocks, then you'll have 5 times 4, 20 bytes will be present. However, what I noticed is the software allows you to do that. Now the way you use this section is you just have to first populate the data. Assume that I would like to write from block number 14 say to block number say 20 or anything. Okay, block number 20. So you use this block 14 and say block 20, and I'm going to clear this commands. If you hit write, so in theory it should have worked. However, the software gets a error message. And in fact, whenever there is an error, in fact, there is no response at all from the tag. If you look at this the request and response structure, now this is what the software has sent to the tag, but the tag did not respond with any that even the error. So it looks like the tag has completely ignored this command. Now the reason this thing has happened is, now this command, even though it's in the specification, it's not implemented in the tag. If you see the data sheet of SLI, you can see the read multiple, you can see write single block, but there's no mention about write multiple blocks. And if you also go and see this the TI tag, this is the TI tag HFI plus. These are the list of commands supported by the tag, but here also you don't see the write multiple blocks. So it looks like the tags what I have got in front of me, none of them support the write multiple blocks. In fact, there is a mention here, sorry. So if you look at here, write multiple blocks, there is a mention about this command, but there is a dash everywhere. So that shows even TI tag does not support write multiple block. So you might come across a tag that that supports write multiple block. In that case, you will see this command working. So next I would like to show you what these custom commands are. You don't find any information about custom commands in the standard specification, because custom commands purely depends on the tag manufacturer. Now this is the SLI data sheet, and this is where you can find information about custom commands. There is a custom command called inventory read, and this is very similar to the inventory command. In addition to what inventory command does, this command will also return you more information. So I would say these custom commands are kind of a shortcuts, so which will do the functions of more than one command. So basically this is the custom commands are used to enhance the operations or make some operations quicker. So I'm going to show you how to use this inventory command, and these are the structure, and in all these custom commands we have to pass the manufacturer code. The manufacturer code is part of any tag UID, and if you look at here, this particular command has got it has got the structure is too much to see for the first time. Now here you can see here it has got everything more or less. We know most of the blocks here, except we have to send the custom the manufacturer code, which is 8-bit, and this is a standard inventory command structure which I've explained this in my videos on anti-collision in ISO15693. So because this is an inventory command, when we send this command we have to have the inventory flag set to 1. What this description says is, this command returns the UID plus it also returns the data. So we can use this command to do both inventory and as well as to get the and also to read some number of blocks from the from the tag. So there could be more than one custom commands, and every tag manufacturer, in fact every tag type, will have its own custom command. This is a SLI command, SLI tag. You might see more custom commands in SLIX and some additional custom commands for SLIX2 and so on. So we are going to come back to the custom commands as and when I discuss about a specific tag. Now here there are two types actually. The other one is the fast inventory read. Now this is very similar to the first one, except the return data is transferred with the higher speed. So again this is all to do with the bit rates and bit frequency, which I'm almost try to keep away all this speed from my videos. But to put in simple words, the fast inventory read is same as that. The only thing is the data returning from the tag comes at a higher speed. I'm going to show this as well. So if you look at the custom commands for a TI tag, there are two, which is called write to blocks and the log 2 blocks. Looks like you can write 2 blocks at a time. So back in this software, if you go to the section I code SLI, you can see here it's called Inventoried. In fact, there are more custom commands, I suppose. If you look at the SLI, see, SLI has got a feature called EAS. If you look at this, this EAS, this is the EAS feature. Here also, this also is a part of the custom command, and here also we have to send the manufacturer code. So the EAS feature is available only in I code. It is not available in the TA tag. So again, this becomes a part of the custom commands because this is not part of the standard. Here also you have to send the manufacturer code. So wherever you are going to send the manufacturer code, those commands will come under the custom command category. So likewise, you got reset EAS, and in fact, in this software shows you the EAS feature of the I code SLI. Now, if you look at if you click this alarm thing, so this returns the EAS pattern. You can set and reset and lock as well. You can lock the EAS feature of this tag. So this tag is already locked. Probably in my next video I'm going to show you in a brand new tag how this set and reset thing works. So if you look at this inventory read command, this is a custom command and this is an inventory command. To use this feature, I have to first go and set the inventory, and also you have to set the inventory to the slot 1. So I'm going to keep more or less everything is the same. I'm going to read from block 4, say to block from block 4 I want to read 10 blocks. Give send. So I'm not using this data here, but this is just for you to show how to use this custom commands. If you look at this command structure, this follows exactly what the documentation says. And if you look at here, so you get the data, you get the full data here. So what you just received here is the data starting from block 4 and 10 blocks, and you'll always get one block more than what you specified here. That's what documentation says. I'm also going to use one more flag in the custom command. So I'm going to use the option flag as well. Now what we just saw is this one. So here you get the flag followed by the data. If the option flag is set, you'll also get the rest of the UID. Now you can ignore this for the time being. Probably I might have to make a separate video on that. So you will get the UID plus the data. So I'm going to set this option flag tick as well, then send the same command, but this time you will get the flag followed by the UID of the tag followed by the data. Now this is what the fast inventory is. Inventory read is, you'll get the inventory. Just a normal inventory will return you the UID of the tag. You might get DSF ID as well, but here you get the UID followed by the data. The next thing is about using the fast. Again, this is going to be just an overview, and there are so many technicalities on what this fast means. So in order to use the fast, if the fast is clicked, the software is going to use a different command altogether. It is the one with the fast inventory command with the command code A1. So if I use that, if I send now, you will get error message because in order to run this you have to set one more flag. So it's not the flag actually, so it is something you have to do on the configuration level. Now here you have to load a different configuration. You have to load the next one from the receiver side. You're going to expect the high rate data, I'm going to load that. Probably, this loading the configuration, we might move that into this screen as well. So if you send the same command again, so you got the data. Now this is basically telling the tag to use the high data. It also means the reader is also ready to accept the high data rate. So we just saw how to send these custom commands. Probably next videos I'm going to focus on the various tags like SLIX and SLIX2. And one thing which I also mentioned in my earlier part of this video, that I'm going to show you how to differentiate between SLI, SLIX and SLIX2. For the best thing is to see the documentation. So you can find out what type of tag is that by looking at the UID. Now this is the data sheet for SLI. Now this is a standard UID description. It says this is the UID file, the 6th byte tells you the type of the tag. If it's 0, 1, it's a SLI, and here the 7th byte is the manufacturer code. And this is the documentation of SLIX. Now here, if the bit 37 is the bit 37 comes here in this the 5th byte. If the bit 37 is 1, so this is SLIX. See, SLIX supports password protection, that we are going to see in my future videos. Now if it is 0, this is SLI. So the bit 37 will be 0 for SLI tag, it will be 1 for SLIX. Again, if you look at the documentation of SLIX2, so this has got clear information as well. Now here, what you can see here is you have to now consider bit 36 and bit 37. Now if it's 0, 0, it's SLI. If it's a 1, 0, it's I code SLIX. If it is a 0, 1, it's I code SLIX2. This is exactly what the software is doing here. So the decoding happens at the UID level. I'm going to show this again. So here it's SLIX. Again, I'm going to change this with the SLI. This is SLIX. If you activate, you get SLIX. Again, everything is stored in this byte. And after that, if I use the SLIX2 activate, it says again it's encoded here in this byte. Okay, so that's all I've got in this video. In my next videos, I'll be probably trying to show you how the SLIX and SLIX2 card works. Thanks for watching.